Thank you for inviting us. We appreciate you having us on so that we can share what we're working on. And of course, we're always looking for ideas and the feedback. So we may get some really interesting ideas from the questions we get today. So what we wanted to do was come talk to you a little bit about, start with the high level picture of who we are, what we're doing. And then I'll hand it over to Dr. Choi, who'll get into the specifics of some of the work he's doing with applying computer vision. So with that, if we could go to the first slide, please. There you go. So the what we are trying to do at UPS is create what we call the self-healing elastic smart logistics network. So what by that, what we mean is that while we can always if you think about it, our business is simple at a very high level. We take things from one place and move it to the other place and deliver it. But at the same time, we also have to accomplish a variety of objectives, which is making sure we meet our customer needs and improve the customer experience, reduce the costs, make sure we provide the service at the least cost possible, and of course, create new products and services that our customers want and enjoy. And then last but not least, do it in the most sustainable way so that we don't add to the emissions in the world. So so what we're trying to do here is put the pieces together to accomplish that. If you could hit, who's controlling the slides? So we start off with, of course, the looking at what the customers are looking for, and our focus is creating what we call the best digital customer experience, and our primary focus on three big areas of focus: small businesses, hospitals, and of course, the expertise we bring in serving more complex logistics needs for international customers. And we think about our business from three angles, right? Go ahead and please enter all the three. I don't know who's controlling it. The way we think about it is that we pick up and deliver packages. So this is the final mile. So we pick it up or deliver it, which you see on the bottom right corner. We also have to move the package, which is on the left side, things either in airplanes or trucks, through our buildings, handle it, sort it, do whatever is required to move it. And then last but not least, we have a variety of signals that we get, both from our customers and also from what's happening in the network, be it weather events, etc. And then put those together to accomplish what we're trying to accomplish, which is serve our customers across a variety of locations, be it with deliveries or be it with UPS stores or drop boxes, lockers, etc. So a lot of this, what we do in our advanced technology group at UPS is what you see in the center, which is a lot of the building blocks of the future to make sure that we can get ready for the future, which is a lot more automated and smart compared to what we've done in the past. So that's basically the vision of what we're trying to get to. If you go to the next slide, please.
So from here, I'm gonna talk about self-healing network. Thanks, Bala.
Okay. See you, Youngjun.
By the definition about the self-healing network, it's like auto-remediation, right? I think it's a great example is, let's think about like airline network, right? And today, let's assume there is hurricanes around the Texas regions, right? Then airline network will be shut down, right? In terms of like UPS perspective, we need to continue to support like our customer service. How we can do that, right? So we can use different modalities like ground, like package cars and those kind of things, right? So these kind of activities, without any human involvement, we are calling the self-healing network. Right? It's a little bit complex, the definitions, but I try to decompose these definitions using the control theory. Okay, so if you look at the like control engineering field, there is like FDIR system: fault detection, isolation, and recovery system. basically it can find fault and then isolate this fault and then also fix it. That's the kind of process. So simply there are four steps using the various sensors. You can do the sensing, and then second step is based on the sensor information, you can do the detection. It means that we can identify the abnormal behaviors, right? And then if we discover that one, and then we can do the isolation, and then we can do the recovery phase. So today my focus is the sensing and detection part, right? So especially for the sensing, we can use a variety of sensors, right? We can use GPS, or we can use sensor IoT, including RFID sensors, to collect some visibility in the logistic network, right? So here I really want to highlight that computer vision is very critical because we can provide a better or new type of visibility inside of a logistic network. So because of that, my talk is focusing on the role of computer vision in the logistic network. Okay. Let's think about what is the computer vision, right? So most of you, I'm assuming you are experts who are doing some similar kind of research, but just in case, I want to highlight what kind of things we can do using the computer vision. So in the logistic field, we all know computer vision can do the object detection, multi-object detection and tracking, right? So let's say there is a conveyor belt and then there is a parcels, right? First, UPS perspective, we want to understand what type of parcels, right? It can be rigid box or it can be polybags, flexible polybags, right? Also, we want to understand size, right? Using the computer vision, we can provide those kind of visibilities. Okay. And then second thing, using the computer object detection result, we can do the counting, right? How many boxes are in the specific locations, right? And then next, we can also do the localization, right? It means that let's say we have a stereo vision cameras, then using the point cloud information with object detection, we can do where is the parcel location is, right? Also, we can use the LiDAR sensors. We can get the very rich point cloud information using the LiDAR sensors or the time of flight, the 3D camera information. We can do the localization. And the last thing is decoding. So decoding, we can read the characters, or we can read a QR code, right? One of the great examples is, so because of pandemic, if you go to the restaurant, we are using the QR code to get the menus. So this is a very representative examples, but we all know there are a lot of things computer vision can do. It means that nowadays many universities are working on the motion tracking, right? So we can use those kind of things with some classification algorithm to identify all our workers doing the safe jobs, right? It means that there is no safety issues. There are many things that we can do. Okay, so now we have a brief understanding about what kind of computer vision we can use, right? So now let's look at the use cases. Okay, so left side there is indoor examples. First one is sortations, right? So if you go a UPS warehouse, we try to automate some of the sorting process, right? So let's say I have a robotic arms, right? So in order to use the robotic arms, first thing we need to do is we need to understand what parcel I need to pick, right? We need to understand the parcel types, right? We need to understand the parcel size, also where I need to grab, right? Computer vision can provide those kind of information, right? Let's look at the second example, trailer loading quality. So this is very important. So every day there are a lot of trailer movement around the US, right? So one of the important thing we need to improve is trailer utilization, right? So we want to minimize number of trailers. Also, we want to minimize the travel distance, right? Also, this one also align with the sustainability impact because we can reduce the miles, right? So this is a very critical path. So using the computer vision, we can classify this road quality is good or not. So because the computer vision is very important. The last one is last one in the indoor side. One example is package conditions. Right? Sometimes on the conveyor belt there is open packages or damaged packages. Right? Those things is very important because let's say conveyor belt stopped because of damaged the packages, then UPS may have significant the loss. Right? Because of that, we need to have feasibility about those kind of abnormal package conditions. Let's look at the outdoors. So at the final mile, there are like various activities in the robotics companies, right? Small delivery the robots. Also there is like self-driving cars, right? Using the computer vision, we can support like some feasibility for autonomous navigation. And then second one is the on-road examples. Let's say now UPS drivers drive the package cars, right? Using the computer visions, we can provide some information or surrounding the package cars. It means that we can provide like some cars around there, right? We can provide like traffic information. Also, we can provide route information as well. Right? The next one is the yard management. If you look at the UPS warehouse, around the yard, there are a lot of dynamic movement, like shifters and others, right? Using the computer vision, we can have a visibility about those kind of dynamic object flows, and then we can optimize those kind of flows. So because of the computer vision is very critical. So now I talked about what kind of problem we can solve here based on our experience, and I want to share what is the key design approaches and considerations when we start building computer vision models. Okay. So first thing is I really want to highlight that we need to build the right computer vision models with better data strategies. Because if you purely rely on the computer vision models, your model may be very complex or very heavy, right? But if you use some existing data, you can significantly simplify your computer vision models. I really want to highlight these ones. The second one is the digital twin models. We all know when you do the object detections, we always have data unbalance issues. We try to overcome those ones. We use various data augmentation techniques using the perturbations, or we use the GANs, generative adversarial network. Right? This is good, but still it's not enough, right? So because of that, I really encourage you to use the kind of virtual simulation environment so that you can do better the data augmentation with some perturbation about the environment in the virtual simulation environment. Okay. Next one is cloud and edge-based AI model deployment. So UPS, we have old facilities 40, 50 years old, or we have new facilities, right, recently built. It's fully automated, not fully, but mostly automated, right? So depending on the facilities, the network infrastructure is very different, right? So it means that you need to have two different options, and then based on the facility environment and constraint, you need to do some trade-off study, which option is better. And the next one is life cycle AI model management. So UPS has many facilities in the US and globally. So in order to deploy the model, you will have multiple models depending on the locations and parcel types, right? So you need to think of how we can manage all different models, right? Also, you need to have proper CI/CD pipelines, continuous integration, and continuous deployment in our environment. So these four elements are very critical when you build computer vision models. So now I talked about, what is the computer vision and what is the use cases, and then what is the key design considerations. And then I'm gonna just share what kind of activities inside of ATG Robotics AI Lab we are working on. Okay, here is the video. So we are working on some of computer vision activities using the stereo camera or monocule cameras, depending on the problem. Also, we have the robotic research platforms. We want to explore diverse things. Also here, we try to use some lane detections to improve autonomous navigation. Then we are working on various the computer vision research at UPS. Okay. So now I want to focusing on the case studies. I think most of you are excited about this topic. So today I'm going to talk about Tele-Operation. Why Tele-Operation and UPS? So Bala Ganesh talked about self-healing network, right? So if you look at the self-healing network, UPS has various assets. So But so in order to manage those ones, I believe computer vision is very critical. So UPS, we have over 500 aircraft assets. Right? And then also we have 100,000 the ground assets. Okay? So we are working on the future technologies like small robots. Right? Also we have flight board team doing the aerial robotics platforms. Right? So indoors we have different robotic platforms. So we are kind of transition phase from the manual process to make a more automated process. Okay. So in here, the computer vision is very critical portions. Right? Also, because of technology constraints and limitations, we cannot make a fully autonomous level 5 autonomous capabilities right now. Right? So because of the tele-operation capability is very important. So here, I want to give a little bit more details why tele-operation is important, how we can commercialize these kind of technologies. Right? So let's look at the first stage. So first stage is typically we do the pilot. It means that we are focusing on the testing specific technologies. Okay, working either government or other companies. Okay? And then second step is we normally do creating the infrastructures like 5G working with other 5G network providers. Also, we need electric grid to support different electrified future robotics platforms. Right. Also, we need smart cities. So this is we call infrastructure phase. And then once the autonomous technology is matured, then we'll have fully autonomous the system assets, right, in the logistic field, right? Then we can have one-to-many operation environment. It means that one operator can manage maybe 1,000 robotics platform in the future, right? So now, our phase is a kind of infrastructure phase. It means that the autonomous navigation capability is not matured yet. Because of that, some portion we need to use the tele-operations, right? So I want to highlight that. So let's look at the more details. So we have different modalities in the future network. So maybe we can use autonomous shifters in the yard, like warehousing environment, and then also last mile robotics. It can be aerial fleet or ground fleet. Also indoors, there is various platforms. One of the examples is autonomous forklift, right? So all those things, because of technology limitations, we need to rely on the tele-operations in some edge cases, right? So this is very important because it enabled us to use the autonomous fleets now, right? So what is challenges? I want to talk about those ones. So if you look at the 5G network provider in the US, here is the maps, the right side. So 5G, depending on the cities and areas, the network bandwidth is different. It means that there is some network challenges I want to highlight. If your network is not excellent, then you may have some image streaming challenges. Right? So because of that, we pose a kind of research question. Right? We are fleet operator. So in order to do the tele-operation, how we can advance tele-operation environment under current network challenges. Right? That's main research question we want to answer. Okay, before talking about what's our answer, I want to introduce our research robotic platforms. Okay, we use the Boston Dynamics, the Spot, the robot walking speed. The maximum speed is 3.5 mile per hour, but here, as a test case, we use the 2 mile per hour. Okay, and then as you can see at the left side, Boston Dynamics has the 5 different cameras, and then for the tele-operation, we use the 2 front cameras. Okay. Right side, it shows the top payload. So our UPS, our ATG teams, we developed the payload system. It has a NVIDIA Jetson KX2, and also we use the GPS, the RTK, and also we have other embedded system inside of the electric enclosure. Okay. So now I'm gonna talk about our tele-operation architectures. So we have the Spot, Boston Spot. It has, I told you, we have 5 different cameras. there's two front cameras, and then there side two cameras, also back side there one cameras. And we have the GPS RTK, so we use the SLAM for the localization. Okay. And then also we have the JSON TX to get all those video camera information from the spot, and then we do some image processing and localization, all those things in the text too. Then for the Tele-Operation environment, we are getting the images from the JSON, and then we try to do some data manipulations, and then we create a kind of JavaScript based the front end so that we can do the Tele-Operation. This is the kind of high level architectures we have developed. Okay. So now let's talk about how Robotics AI Lab try to solve network challenges using these robotic platforms and Tele-Operation architectures. So first thing is that let's say we have the robot. The robot can provide the images from the front cameras, 640 by 480, right? And then the onboard edge device will get the images. Here, our first idea is okay. Let's measure the ongoing current network bandwidth, and then try to modulate depending on the network speed, right? So based on our observation, if your frame rate is over 7 or 8 frames per second, I think it's okay to control the robots. But if it is below, then you will have some trouble for the Tele-Operation. Okay. So because of that, we create this modulator. We have 3 different image resolutions, as you can see here. And then once we determine the resolutions, and then we conduct image stitching, because front camera there is 2 images, and then based on the features, we try to stitching the images. And then based on the stitched image, we streaming. And the ground stations, we receive the data, and then using our front end, and we use our Tele-Operation environment. Okay. But this is several challenges. The first one is that if your network bandwidth is low, right? Still, you need to send the low resolution images. It's a little bit blurred, so sometimes it's challenging to properly control your robots. And the second challenge was the image stitching requires high computing powers. So because we want to avoid computing the image stitching on the edge device. Okay. So there are 2 challenges we want to cover. So because of that, so we are thinking, okay, how about sending the just low resolution images to the ground stations, okay, without any image stitching. Okay. Then on the ground station, how about upsampling these images? So we pose question, can we use some upsampling technique? And we did some research survey. Okay, what kind of method out there? Traditional computer vision side, we have an upsampling method, interpolation, nearest neighbor, bilinear, and bicubic. Right? And also we have a learning-based method like transpose convolutions. And because of the deep learning advancement, many researchers are working on the super resolution. Right? So there is pre-upsampling, super resolution, and post-upsampling, progressive upsampling, depending on your architectures, how you can make better resolutions. And then also there is generative models. So here we use SRGAN, super resolution generative artificial network. The reason is that so this one is very cool, and it can provide precise the upsampling the images, surprisingly, compared to traditional or other methods. And then the other thing is that it used mean square error for improving the pixel accuracy, and then the other thing they use the artificial the loss from the discriminator. So because we use this one, and then from the paper, I just put the images because it clearly show difference. The left side is the traditional computer vision method using the bicubic, so we can clearly see there is some blurred. Right? SR resonate using the resonant architecture to the super resolution, it's a little bit better, right? But if you look at the SRGAN, it's much better, and then if you compare to the original, it's almost same. Of course, we cannot copy and paste, right? Because the deep learning just running the like features. But in terms of like visuals, it's very similar. So based on this research way, okay, we are thinking, okay, let's use the super resolution SI again. And then we created the bottom architectures, as you can see on the left side. Now we are just sending the low resolution images. And the onboard edge device, I don't want to do any computations, just sending the image. Okay. In the ground station, we apply the SI again, super resolution technique, right? And then once we have them, we have the good high resolution images, and then we do the image stitching here. And then we can use those one for the Tele-Operation. So the advantages, so now I eliminate all those computations regarding the image stitching, and then we can do fast streaming, right? We are sending the low resolution images, and then our image is improved for the Tele-Operations. So here is the video. We create the video side-by-side comparisons. I'm gonna play the video. So this is one example if your network is bad, and then this one is talking about the architectures. And then left side is the first architecture, and the second one is using the super resolution. So you can see here like super resolution is like slightly better image quality. Okay. And then the left side, it's a little bit blurred. So we use bottom line spot to test these proposed architectures. Okay, here is the conclusion. So first, we believe computer vision will do the critical role for like future smart logistics network through providing new type of information. Second one is Tele-Operation is very important for like autonomous systems, and because like there is edge cases. So in order to work on those ones, we need Tele-Operation environment. And then in the case study, we introduced like super resolution the examples. Right? This is the main objective we want to overcome like any network challenges. I think that's all. Thanks for listening all my presentations. And now our team is hiring. We really want to hire like computer vision persons and MLOps and robotics. If you want to do innovations, if you like the like agile environment and then working with like talented like scientists, feel free to contact me. I'm happy to answer like any questions. Thank you so much.
Awesome. Thanks, Dr. Choi. I have just one request. You were talking from your phone. Can you join from your laptop, because it would be great to see your face and when we continue our Q&A session.
Oh, okay.
No, we can see your face.
You can see my face because.
Wait.
Oh, I can't. For example, I see the phone number.
Oh, you can see if you see the like other people. There is Youngjun Choi. I open the camera. Yes, you know.
Yeah.
Okay, guys, do you have questions? I see a question from Mike. Does the CR model handle low lightning condition?
That's low lighting. That's a really good question. So we try to do some data augmentations because there is low light, right? Especially like, if you want to operate the robots the outdoors, right? Like cloudy, definitely there is some light degradations, right? Also like if you operate the robots around the evenings, right? Definitely like dark, right? So we try to do the data augmentations, but it's challenging. It's challenging. It works, but it's challenging because your the image pixel variance is very small, right? So because it's very hard to run the features. But we can see like some improvement. But if like the environment is really dark, then we may need like additional like sensors, maybe infrared sensors.
I'm wondering how do you handle like data annotation? Do you use some external tools, or you have your internal team of annotators? Because you mentioned in your presentation that the data strategy is important, and I assume the strategy applies like sort of consistent work with data, right?
That's a really good question. So our team is very agile, and we have some computer vision development strategies. So first step is we try to identify the problem, right problem. That's first. Okay. Once we define the problems, and then I have my team members. We are discussing together, and we try to come up with what kind of a computer vision model we're gonna build. Okay. And then we spent like 5 weeks, and then we hired the internal people to label. Right. This is a prototyping phase because I don't want to rely on the external companies because it takes some time, and also there is some document process. I want to minimize those kind of times, right? Because I quickly make like annotators, internal annotators. Okay, and then we do like depending on the problem, maybe we can do like 5,000 labelings, large data, just showing the like prototyping result. Okay. Once it is like proved from the like prototype phase, then I have like external companies who can support in large data sets. So we are labeling like 300,000 the data. It depends on the problems. Okay. Also, I told you like we also we are also planning to use the like virtual simulation environment because data unbalance issue it's very critical. We can clearly see that. Also, it's, especially if you think about like damaged like packages, right? It's very hard to catch like those kind of images, right? Labelings, right? So because we want to use like virtual simulation environment. So
Yeah,
my
so
answer is we are doing the both. Yeah.
You do both, but like as I said, like you mostly rely on your like internal annotators.
No, external. So once it is approved, and then when you do the large scale labelings, right? Then we're gonna rely on the external. So we have like both work streams.
Okay. I see a question from Smita. Are the robots trained in specific environments? Does a city robot have to be retrained if it moved to a rural area?
Yeah, I believe so. So based on like our like robot testing, right? Depending on the like environment, your feature is totally different, right? So we need to retrain, but not large scale data, but we need some level of data augmentations because the environment changes. Also, another thing is, let's say I want to use the robots like in the US, and also I want to use this robot to like Europe or Asia. The house shape is totally different, right? Also the road condition is totally different, right? So because of that, we need to do some level of data augmentation. If you do like some image segmentations, you can clearly see like segmentation has some challenges if your environment is changes. Welcome.
Thanks. Thanks, Smita, for a question. So I see a question from Trevor. This super resolution work appears to be a method to limit bandwidth requirements from the edge device to command and control. Where other losses, where other lossless compression techniques explored? Trevor, maybe you can ask your question directly.
Yeah. When the last section appeared to be a way of sending lower resolution images, so that way from the central command and control, you'd have a high resolution image to work with. There's a bunch of techniques outside of even computer vision that allow for image compression or different codecs to limit bandwidth requirements. Was that explored at all?
Yeah, that's a good question. So actually, that's a really good question. When you send the images to the ground station, we compressed. Okay, So this is like just about like full resolution part, but we compressed because we don't want to like send the large data. Yeah.
Thank you. I appreciate it.
Mm.
Okay, see question from Mochine. Sorry if I pronounced your name wrong. How robot failures are handled, and how much is the risk to interruptions due to failures?
So here, like, I want to ask, what's the definition of the failures? So Tele-Operation environment is a kind of additional tool if autonomous navigation is like performed well, right? So like edge cases, emergency cases, right? So because we want to use a Tele-Operation environment, right? Here, I want to understand the, like, can you give a little bit more details of what mean like failure?
Mochine, can you please unmute yourself and clarify your question?
So yes, hi. So yeah, my question is about failure that can occur based on maybe errors that have, like, the robot cannot accomplish the mission, and because of that, maybe some procedures and other operations can be stopped or interrupt. So just question, like, if you, like, how do you handle this type of things, and basically what is the risk of having kind of this events happening?
Got it. Thank you. Thanks for clarification. So that's a good question. So let's say autonomous navigation failed, right? So our procedure is teleoperator is managing like multiple robots. Okay. If there is like abnormal behaviors, then we can see which robot has issues, right? And then we try to teleoperate to avoid that emergency or abnormal behaviors. Okay, that's first thing, right? Second thing is that like we are currently this is a little bit early stage. We try to build like clear operational procedures, right? So we can do like some level of already starting the robots if robot cannot be controlled by the teleoperations, right? Or if completely dead, then we may pick up the robots, right? So now we are doing the like pilot stage. It means that we try to understanding those kind of like operational challenges, right? What is the right operations, right? Because we want to like make a like frictionless operational environment, right? That's our goal.
Thank you.
Question from Faisal. If you sort of give any thought on security of ML models deployed on the edge or robot. For example, it has been shown that cleverly crafted inputs can fool deep learning models. So any concerns regarding this in your environment?
That's a really good question. So are you talking about the adversarial attack? Because now I'm doing one of PhD thesis committee, his topic is adversarial attack. It means that like one guy like keep attacking. It means that, let's say now you can see the UPS logo, right? If you do the adversarial attack, I can tell a computer vision model tell this is FedEx. Okay, this is the examples I'm giving you. Okay, so are you talking about this kind of adversarial attack or what's the name?
Yeah. That's what. That's what I meant.
Yeah.
I was just,
Yeah.
So can you repeat the example you gave about the last sentence you said? You gave an example. I didn't quite get it.
So if we see the like this logo, it's clearly like a UPS logo, right? But if I do the adversarial attack, it can be like, I don't know, maybe Coca-Cola or other objects. So it means the computer vision recognize as a like other brand, not UPS brand.
Okay.
Means the adversarial attack can mess up.
Okay. Yeah. So there is some work going on in this area. You mentioned like a PhD student working on this.
Okay. So it's very hard to hear, but I can give the answer. So based on my understanding, there is a huge community working on like how we can overcome those kind of adversarial attack. Okay.
Yeah, basically like adversarial attacks. Have you basically anticipated in your work this this scenario, right, of having adversarial attacks?
So it can be like now we are like technology testing phase, right? But security is a very important topic, right? So we consider those kind of problems, but now we are a little bit early phase. But that definitely that is a really good question we need to answer. Yeah.
So, but as I understood you haven't faced like in production this kind of situation.
No, we haven't.
Mm-hmm. So I see a question from Iman. So the only purpose of CR is to make it easier for a human to control the robot. Is this right? How do you quantify that?
That's a good question. So I think if you look at the like SIGM papers, they use like human perceptions. It's a little bit subjective, but it's very hard to quantify, right? Because we don't have like true right information unlike other computer vision models, right? That's my answer. But definitely challenging.
Iman, do you want to add something or? Okay, Iman is not responding. Okay, yeah, thank you. I'm wondering, you know, the company is so big and you have also like employees in Europe and basically in those countries where the legislation regarding the data and how it's collected and handled is different. I'm wondering, do you have any challenges when the teams in different like countries with different legislation about the data sort of working together? What are the challenges in collaboration of those teams?
So this is really a good question, and if you want to build an enterprise level computer vision solutions, this is one of the critical questions we need to answer. Okay. Last year I spent like almost 6 months to talking with our legal teams because there is like PIA issues, right? In the US, surprising, depending on state, the regulation is very different, right? It means that the PIA level is different. So Europe, it's more strict, right? So we need to follow the law, right? So it means that we need to closely work with our legal teams. Then what is we can do, we cannot do. So based on this one, we need to build like computer vision models.
Yeah. So basically, when teams from the US and Europe, when they work together, it's also the process goes through like the legal team who.
Yes.
I'm wondering, Dr. Choi, how when you deploy your models into production, do you? I'm just curious. What is the proportion of tools that you build internally versus tools that you use vendors? For example, when it comes to like deployment, do you guys build your own like platform and pipelines, or you use like vendors as well?
That's a good question. So our strategy is we want to be very agile. Okay, and then second thing is that we want to collaborate with our partnership companies. It means our core team is thinking about right problems and then developing the like prototyping solutions. So once it is validated through the like actual physical testing in the sandbox, our sandbox the facilities, right? And then we are quickly make a transition, working with the partnership companies. And they're gonna help like scale up. And then my team is tackling like other problems. So in this way, like we can be very agile because if you start to working on the like rollout, like deployment, you will be slowed down. So that's our strategy.
So basically, as I understood, you are using like vendors as well in
Yes,
your.
yes, correct. Yes, partnership companies. Yeah.
And I'm wondering how often do you update your models that are in production?
So we have a like CI/CD pipelines. We are keep monitoring like model behaviors. So like over detection, we can use the confidence levels and then keep monitoring it is shifted or not, right? Based on those observations, we try to make a decision.
How, I mean, if it's not a secret, how many models in production do you have?
So I have been at UPS like little bit over 2 years, okay, and then last year I pitched the UPS machine vision programs, computer vision programs. So we are about the kind of deployment. So it's the first model, but we have like a list of like use cases. I showed like some of the examples. So we're gonna tackle one by one, depending on the like technical challenges, also opportunity side, right? How big impact computer vision model can do, right?
Actually, maybe we should do another talk, maybe like in 6 months from now, right? And we can see like basically that use case, right? How that model performs when it's already in production. That would be really interesting.
Yeah,
that would
definitely.
Guys, do you have other questions? If there are no other questions, I just want to remind you. Oh, okay, I see a question from Iman. What else is your team working on? Basically, what other research projects do you guys have?
So currently, like my team, the main focusing is last mile robotics and also the computer vision part, like to provide better visibility to improve like our smart logistics network, right? Those two things are kind of main project. But our advanced technology group, we are innovation factory. It means that our goal is transforming our legacy delivery network. It means that if we can find a good problem, we can improve our network, then we can tackle it. There are a lot of things, like ground robotics, aerial robotics. We have aircraft inside the buildings, manipulators. There are so many problems we can tackle. So depending on our bandwidth and our interests, we try to define the problems one by one. So it means that there is like many other opportunities that we can tackle.
That sounds great. Just a reminder that Dr. Choi is hiring, and if you're interested to work with his team, please send your resume to him. And the recording of this talk will be available like in a week or so. I will be posting on our Bug Out Slack. I'm just sharing once again the link to join our Slack if you are not there yet. If there are no other questions for Dr. Choi, I think we can wrap up our meetup for today. And it would be like really great, Dr. Choi, to have you maybe in 6 months from now and learn like about the progress about your research work.
Yeah, I will. Yeah, please invite us. Yeah.
Thank you. Thank you for your time, and thank you everyone for joining this talk today. Have a nice day, everyone.